Good afternoon, everyone, and good afternoon, Professor, and everyone. My name is Anutara. I'm from Aesthetic, Restorative, and Implant Dentistry, Chulalongkorn University. I would like to present my research. The topic is effect of adapting resin composite to fiber post on fracture resistance and fracture mode in endodontically treated teeth with flat root canal. For the background and rationale, the primary goal of dentistry has always been to preserve the natural teeth. However, when the tooth is devitalized by caries or trauma, endodontic treatment is needed to preserve the natural tooth, while endodontic treated teeth, which from now we will refer as the ETT, retain tooth structure, retain the biomechanical properties comparable to the white teeth. Various factors, including the remaining dentine, the restorative materials, and the restorative techniques, are essential for the success and the long-term outcome of the ETT restoration. Several studies found that the prosthetic aspect are the most common failure of the ETT failure. When ETT presents substantial loss of tooth structure, post and core are typically required to provide resistance and retention for the definitive restoration. Numerous post materials, fabrication techniques, and post system have been proposed to compensate the lost tooth structure. In the past, the metal cast post was the widely accepted technique to provide adequate retention for the restoration in the tooth with insufficient remaining structure. However, it has multiple advantages such as intimacy contact to the post space, the less post preparation, the uniform thickness of the cement, superior bonding strength when compared to epoxy resin in fiber post. However, the study showed that metal cast post has many concerns, including unpleasant aesthetic appearance, more share time, the stiffness of the metal cast post. With the increasing aesthetic demand nowadays, and previously mentioned concern of the metal cast post, making the fiber post a widely accepted alternative restoration to metal cast post. The major advantages are the aesthetic appearance, less share time, and cost effectiveness, and similar modulus of elasticity to dentine, which may result in better stress distribution to the root canal. Despite all the advantages, prefabricated fiber post has poor adaptation to post space, less fracture strength, and show inferior bonding compared to the metal cast post. In the present, there are many fiber post systems in the market. DT light post is one of the widely accepted with high fracture resistance and successful outcome. As previously mentioned, the prefabricated fiber post, they are usually not adapt well to the conformity of post space, especially in the flat root canal cases. Poor adaptation and poor retention result in thick resin cement, which increase the risk and error in the cement layer. These flaws could further lead to debonding and post dislodgement and lead to root fracture. Several techniques have been proposed to improve the adaptation of fiber post to post space. For example, anatomically customized post by adapting fiber post with resin composite to replicate the anatomy of the post space. The technique can be performed with less share time and processes compared to the conventional technique like metal cast post. It is reported in several studies to have high fracture resistance and successful outcomes. On the other hand, some studies show that no difference was found between the prefabricated fiber post and anatomically customized regarding fracture resistance and bonding strength. So nowadays there's still a controversy whether this technique has a beneficial influence on fracture resistance of ETT or not. So the research objective of my study is to compare the fracture resistance of ETT using fiber post with and without resin composite adaptation. Second, to analyze the effect of adapting resin composite to fiber post on fracture mode of ETT. For material methods, teeth were selected according to inclusion criteria. After measuring using the digital caliper, teeth with similar dimension were chosen. The number of samples was calculated using G-star power program and the data from previous study. A total of 24 teeth were selected. For specimen preparation, the teeth were sectioned perpendicular to the tooth axis 2 millimeters above the buccal CEJ. After that, they received endodontic treatment and the post space was prepared, leaving 5 millimeters for apical seal. With the aid of a digital caliper and periapical films, flare root canal with a standardized radicular dentine wall of 2 millimeters at cervical was created. Size 1 DT light post. The material was quartz fiber, double taper shape. Diameter is 1.5 at the cervical and 0.9 at the apical. After specimen preparation, the specimens were categorized into 3 groups of 8 samples each, according to their restorative approach. The first one is the control group or group C. The specimens were restored without fiber post. Root canal was filled with built-in FR core material. For the prefabricated group, we use, as I mentioned before, the DT light post, just only the DT light post without adapting of resin composite. For the adhesive procedure, we use the OptiBond Solo Plus adhesive and Nexus 3rd generation dual kill adhesive resin cement was used for cementation. In the anatomically customized group or ADT, the specimens were restored with the same fiber post but realigned with resin composite Filtech C350 XT. Prepared root canal was lubricated with water-based lubricant. The fiber post was realigned with resin composite and then adapt into the post space and light kill. After that, adhesive and cementation procedure was the same as the previous group. Following that, the custom core former with diameter of 3.6 millimeter made from the translucent polyvinyl siloxane was used to build core using built-in FR fiber reinforced core material. For the fracture strength test, in this study we used universal testing machine Lloyd LR10K for the fracture resistance test. Specimen was mounted at 45-degree angle to root axis. Load was applied at the lingual occlusal surface until fracture. Following that, all specimens were inspected to identify the failure mode. Tooth fractures in the cervical were classified as reparable, while fracture into middle and third of the root were classified as irreparable. For statistic analysis, we used the SPSS program. Results. From the result of this study, the fracture resistance present normal distribution and record in Newton. The fracture resistance of anatomic group was significantly higher than other groups. Control group present the lowest fracture resistance. However, the prefabricated group show no difference from the control group. For the failure mode, from all the fracture, 87.5% of fracture show to be reparable. 1 sample in prefabricated group and 2 samples in control group show a reparable fracture mode. Chi-square test show no statistically significant difference in failure mode among the groups. Discussion. From the result of this study, different fabrication techniques demonstrate beneficial effect as there was a statistically significant higher fracture resistance found in anatomic group. The statistically significant increase in mean fracture resistance could be attributed to the close and even contact between the anatomic post to the post space. This close contact contribute to improved frictional retention, which could help provide stability of restoration under occlusal loading. Together with the similar modulus of elasticity of material used in this restoration, it results in a more uniform stress distribution throughout the post and dentine complex. Also, in a study by Shifi et al. In 2007, the consistent contact of the post report to have greater sustained seating pressure in cementation. This seating pressure showed to create higher quality adhesive interfaces and less risk of defects such as air bubble in the cement layer compared to the prefabricated post. All the mentioned advantages and higher in fracture resistance in anatomically customized posts could mean less chance of failure of ETT restoration under occlusal loading. Likewise, numerous studies supported the anatomically customized posts have positive direct effect on ETT restoration. The result of this study is aligned with the previous study that anatomically customized posts show increased fracture resistance, and also the study shows superior bond strength found in anatomic posts when compared to prefabricated posts. In a study by Anutara et al. In 2011, as you can see that the stress depicted as red color. This study showed that in anatomic posts, most stress concentration was found in the cement layer, while display lower concentration in the dentine. On the contrary, the stress in prefabricated fiber posts was higher than the customized posts and concentrate more in the dentine. Furthermore, case report study by Da Costa et al. In 2011 and Gomez et al. In 2016 also show that this technique can be done with successful outcome and increase in fracture resistance. On the other hand, a study observed no statistically significant difference in fracture resistance among restoration with different post adaptation and post space. However, in this study, the gap between the post dimension, gap between the post diameter and post space was only 1.3 millimeter, which different from the present study. In the prefabricated group, the statistically significant lower fracture resistance was found as there was a great mismatch between the size of the post and the post space, result in thick and uneven cement layer. This inconsistent cement layer increased the probability of error in both adhesive and cement. This defect could further complicate the restoration and could lead to failure afterward. A previous study showed that there was a larger area of air bubble in thick and resin cement in the prefabricated fiber post compared to the customized post. This statement also collaborates with other studies, indicating that one of the most prevalent reasons for ETT failure was from adhesive failure. Regarding the failure mode, as I mentioned before, this study showed no statistically significant difference in failure mode. This can be explained by the previous mention about the advantages of the fiber post in terms of stress distribution pattern, and also in this study we use the material which is the cement layer and the core material which have the similar elastic modulus to dentine. Remaining radicular dentine was another important factor. In this present study, the indifferent failure mode found across the group can be contribute to the 2 millimeter of remaining radicular dentine at cervical area in this study. This is aligned with a previous study show that 2 millimeter of remaining dentine result in no significant difference regarding failure mode of ETT in various restoration techniques. For limitation, this current research was conducted in vitro and did not take place in intraoral environment. The temperature and humidity level were not representative of a real clinical situation. The load was applied in one direction and one angle only. The adhesive eluting cement system used was only one system. Further study may include the addition of samples, the use of alternative fabrication procedure, the artificial saliva bath, and fatigue resistant testing. Within the limitation of this study, the results suggest that fiber posts rely with resin composite demonstrated significant higher fracture resistance compared to prefabricated fiber posts and without posts. Therefore, anatomically customized posts can be used to restore ETT with wide or flare root canal to increase adaptation and fracture resistance. That's about it. Thank you for your attention.
Thank you very much, Dr. Anutara, for the very informative and clear presentation. I'm sorry that I mentioned your names wrongly before.
It's correct. Thank you.
Your name is Anutara, Dr. Anutara.
Thank you.
And is there any question from the audience about the post adaptation to the flare root canal? Okay, if there is no question, I will ask you some question. You use the adhesive system that you use. What Optibond Solo Plus, right?
The Optobond Solo Plus is the two-step triple H adhesive system.
Why do you use this?
I use this one with the Nexus 3 because there's a research paper that show they mention about the like the dark gel activator between the two adhesive and cement. So I use it to
there's a dark gel activator.
Yes, from the company claims they said they have the chemical that help each other to kill.
Okay, I got it. And you mentioned in the method that you will have a light kill in the host space, right? Do you have a problem with the seating it later? Like how grow the thickness of the adhesive? Because you light kill it before, right?
Yes, correctly. I like kill the first time. I mean, inside the post space, and later we take it out and light kill again. So basically, the procedure was to lubricate lubricate the post space first, and then after we adapt it into the post space, we do the light kill one time, and after that we take it out and we do another light kill to make sure that the resin composite adapt to the fiber post was completely killed. And after that, we try it in, and normally it usually, I mean, fit quite well. But I mean, if it doesn't, I mean, we can adjust by use the burr to correct it a bit. But usually it fit quite well.
Yeah. I mean about when you fix the post, like what is the procedures like when you fix the post?
Oh, the procedure for cementation?
For the normal one, the one without the reline composite.
Oh, I see. The normal one we after
you like kill it.
Yes, I like kill it. I mean after I mean
before you fix it, right?
You mean after I apply the adhesive onto the
post? Yes. After you apply the adhesive into the post space.
After I apply adhesive onto the post space, I have to make sure that there is no pooling of the adhesive by using the microbatch to remove the pooling, and after that we air dry and make sure that there's no pooling of adhesive left.
Okay. So it will not be difficult to insert it in, because normally in the clinical, I like kill it later.
I think, I mean, it's gonna need time. I mean, for the learning curve. I mean, because yeah, like Professor said, it's gonna be easy to like kill later, because I mean if there's pooling of adhesive, you cannot fit the post inside the post space, right?
Okay.
So that's why I need to make sure that, I mean, I have to remove all the excess adhesive.
Okay.
The time is up already.
Our time up already. Okay. Okay. So thank you a lot, Dr. Anutara, for the your presentation and answer.